Many years ago, I was at a friend's party and I met someone new for the first time. And as always, they generally ask, "What do you do?" At the time, I proudly said, "I write mathematics books for schools." And this lady's eyes opened up wide and says, "Oh, do you have any tips for my daughter? She doesn't know her division facts." So I said to her, "Well, how well does she know her multiplication facts?" And she said, "Well, she doesn't know those either." Now, that child had no number sense, and she will never know her division facts until she sees the connection to multiplication facts. In this episode, we're going to explore activities that help strengthen the connection between inverse operations and numbers. I'm a big fan of arrow diagrams because the arrow provides a function or an operation which enables you to backtrack that, essentially reversing that function or operation. Now take a look at this arrow diagram involving the function of addition. In this diagram, the arrow means add 11, so that's the function. Follow the direction of the arrow from 46. What is 46 add 11? We know that is 57. If C is 57, then we know D is 11 more, which is 68. Now go back to 46. How can we figure out the value of B? Well, you just need to ask yourself, what number plus 11 more makes 46? This is essentially an unknown add-end subtraction problem. Because I know one add-end, and that's 11, and the total, which is 46. I can figure out the unknown add-end by backtracking the function, which in this case is add 11. How can I reverse add 11? If I understand that subtraction undoes addition, then I just need to subtract 11, which means B is 35, and following the same steps, A becomes 24. Let's take a look at a different type of arrow diagram involving the function of multiplication. The function of each arrow here is expressed above the arrow, and it shows multiply by 2, or double. If I place a 6 in this box, then the next two numbers must be 12 and 24, which helps you see that when you double and double again, it's the same as multiplying by 4. But what happens when I place 20 here? Then I need to backtrack the function of the arrows. How do I do that? What is the opposite of doubling? Halving. So 20 divided by 2 is 10, and 10 divided by 2 is 5. This means that when you halve and halve again, it is the same as dividing by 4. Arrow diagrams come in many different formats, and for each format you can change the numbers in the diagram and you can change the functionality of the arrows. This will give you hundreds of different combinations of arrow diagrams that you can use with students right across the elementary grades. Now, I've only shown you arrow diagrams involving whole numbers, but you can also use them with fractions and decimals. Earlier, I mentioned unknown add-in subtraction. There are actually three types of subtraction, which you can explore in another episode. But unknown add-in subtraction, which we sometimes call missing add-in subtraction, is actually taught at a very young age. So after introducing it with concrete or hands-on materials, you can use a slider card like this to show the equation. This looks like an addition problem. But it is not. It is a subtraction problem. Why? Because we already know the total. In addition problems, you're looking for the total. But here's the total. It's 9. We have one part, and that's the known add-end, and we have a missing part, or an unknown add-end. So we can also show this unknown add-end, and we have a different problem. That becomes an addition problem, which helps connect the two operations. I can also show the unknown add-in subtraction problem as an equation like this. This is the total. I'm going to take something away. That part is unknown, that add-end is unknown, and it leaves another add-end. In later grades, you can give students equations like these to solve. Now, for each of these, they can either count on or they could subtract from the total. Now, if they use the latter, they're using subtraction to solve an addition equation, which then serves to strengthen the connection between these two inverse operations. Finally, I want to show you an engaging game that can be used to strengthen the connection between operations. This one is for subtraction and it's called take or tally. In this game, students work in pairs and write these digits on the faces of two blank cubes or dice. After rolling the cubes, the first player needs to decide where they can place the two digits in one equation of their column to make a true statement. For example, if they roll 3 and 8, they can write those digits here to make it true. If they roll two digits that cannot be used because they have already filled that equation, or they roll something like 12 and 3, which has no matching equation, then they must write a tally below. The first player to complete 6 true equations wins, but the first player to make 6 tallies loses. Try that game with your students. It's a great game for connecting addition and subtraction because in order to solve the subtraction equation, you must first add the two digits. So this is what I want you to do. 1. Remember that one of the best ways to foster number sense is to strengthen the relationship between inverse operations and numbers. 2. Use arrow diagrams in simple games like those I've shown you. I've left a copy of Take or Tally in the links below. Now, if you have older students, use that as a template for a game involving multiplication. I'm sure you can create one. And finally, if you've seen value in this episode, please give me a thumbs up, leave a comment, but subscribe today so you never miss another learning opportunity with me. See you next time.